Yeah, so hello everyone and welcome back to our sessions. So yesterday we had taken up Venn diagrams type 2 and we were still on the verge of completing it. Right. So yeah, we had done till A difference B and we've convinced ourselves with all of the six formulae. So three more, which is symmetric difference and A difference B intersection C, that is a distributive property, and followed by A minus A, which is a null property. So these three, which we were left out to complete with, and yeah. So asymmetric difference B. So what do we mean by asymmetric difference B? All those which belong to A and does not belong to B. At the same time, all those which belongs to B and does not belong to A. So that is nothing but A difference B and B difference A both. So A difference B is nothing but this, region. Yeah, so this region is given as A difference B and this region is given as B difference A. So yes, both these, shaded regions, if you take into consideration, that gives you the symmetric difference. So basically, you will just omit or you will ignore this intersection, which is A intersection B. Okay, so yes, this is nothing but asymmetric difference B. Did you understand how asymmetric difference B looks like? Okay, so what exactly is asymmetric difference B?
A minus B means which belongs to only A and not B. Union B minus A is nothing but the elements which are present only in B but not in A.
Correct. So that is exactly how this formula has come in. All right.
Yes, ma'am.
Yes. So the previous session we saw A difference B, which is only this much, and B difference A is also only this much. So if you take the union of two, you're getting this asymmetric difference B. And one more thing to keep in mind, asymmetric difference B is the same as B symmetric difference A. Both are the same. Okay, so this is one thing you have to keep in mind. Fine, clear till
Okay,
here?
ma'am.
Yeah.
Is
Okay. So the next thing, which is A difference B intersection C. A difference B, which means it only belongs to A, but should not belong to B. And that intersection C. So wherever that collides with C. Okay, so that region okay, so this is A difference B. Okay, and you need only this A intersection C. I mean, the one which intersects with C. So where A meets C is only this. So the yellow lines represent A intersection C. Okay, and the red lines indicate A difference B. Got it?
yes, ma'am.
Did you really get it or you want me to explain it once more?
No, ma'am, I got it.
Okay. So in that case, if you have to take, what is that? A minus B is the red lines and intersection C, that is wherever A intersects with C, we have put it as yellow lines. So yeah, the intersection of that is, okay, so this much is A difference B. Considering you have three sets C as well, if you see that way, then A difference B is only this. Have they spoken anything about C? No. So are you going to consider C? No. If C is also a part of the group given or the set given to you, then you will not consider C as long as C is given in your questions or it is a part of the group. All the previous formula, we didn't have C as a part of the group. Okay, it was only A and B. We were playing only with A and B, so C was never in the picture. Now that C is coming into the picture, you will not consider. Okay, but is this also a part of A difference B? Yes, this is also a part of A difference B. So yeah, now the place where C intersects with that. So place where C intersect is, where does C, the circle C, and the this one, which is that uh, A difference B, that is the yellow mark. Where is it found? Only in this region. Correct. This is the region where both are intersecting. So this green region is nothing but A difference B intersection C. Okay, so this is the first part of the given formula. So what about the second part? Let us see if it is true or not. So we are supposed to get only this green region even after doing this. Okay, because both should be equal. It should come to the same answer. Okay, so in that case, considering the second part, which is A intersection C. So yeah, A intersection C. What is A intersection C? This much. This whole thing will be considered as A intersection C. Do you agree with me?
Yes, ma'am.
Okay. So in that case, the next half of the equation is B intersection C. So they have asked B intersection C, and B intersection C is this region. So do you agree with me that this is B intersection C?
Yes, ma'am.
Okay. So what have they told here? A intersection C, difference this one, B intersection C. So A intersection C, difference B intersection C. So what does this mean? All that belongs to A intersection C, but should not belong to B intersection C. This belongs to A intersection C, but does not belong to B intersection C. Correct. This is again A intersection C, but not B intersection C. Correct. Is this also, A intersection C, but not B intersection C? No. Both have come here. Is this, A intersection C, but not B intersection C? No. Is this also that part? No. So we are left with this region. So the red mark here is the same as the green mark when we did in the previous time. So the equation on the right hand side and left hand side, both have both have turned out to be the same answer. Fine. So which means they can be equated. Fine. So convinced yourself with this formula?
Yes, ma'am.
Okay. So the last one, which is A minus A. A minus A is all that which belongs to A, but should not belong to A. It's just like telling 3 minus 3 or 10 minus 10. What will it give? 0. 3 minus 3 or 10 minus 10. So here in set theory, the set is called as null set, or a set which has 0 elements in it. So n of null set will be nothing but 0. There will be no elements. Fine. So this is also clear with you?
Yes,
Okay.
ma'am.
All right. So moving on to the next slide. So yeah, not able to move it anyway. Okay, at least here you can see. Yes. So yeah, they have given us a question. In a class of 80 students, 30 like tea, 35 like milk, 25 like coffee. It is also known that 15 like both tea and milk, 17 like both milk and coffee, 14 like both tea and coffee, 9 students like all the three. So first thing that they have given in a class of 80 students, which is nothing but the universal set. So the entire class is 80 students. Among them, 30 should like tea. 30 of them like tea, 35 like milk, and okay, yeah. So 35 like milk, and yeah, 25 like coffee. Yes. So this value we have taken, this we have taken, this we have taken, this also we have taken. Next, 15 like both tea and milk. So tea and milk, this entire thing should be 15. So before we come to that, we have this, all the three intersection region. So that is given by 9. So among this 15, 9 are already placed here. So how many are remaining? 15 minus 9. Okay. So that is how we got this value 15 minus 9. Did you understand or you want me to explain it again?
Ma'am, explain it again, ma'am.
Okay. So they have given this entire group, okay, this entire red region is 15. This entire region is 15. One more thing that they've given us is, hmm, one more thing they've given us is this green region. This green region is the intersection of all the three, those who like tea, milk, and coffee. So that is given to us with the number 9. Correct. So this region is 9. This green region is 9. That we are clear. Now this entire red region completely is 15. So among those 15, 9 are already kept here. Ah, so what is the remaining 15 minus 9? 9 are already here. Total here is 15. So how many is left out? What is the balance?
6.
15 minus 9. So understood how it is 15 minus 9?
Yes, ma'am.
Okay. So similarly, yeah, similarly, so this 15 is done. We have taken 15 minus 9, which is 6. You already told me. Correct. Now, they have told 17 like both milk and coffee. So, in this entire region, 17 like milk and coffee. Among this entire 17, 9 again are already kept here. So, this is 17 minus 9. Okay. So, this is how much?
8.
Correct. Okay. So, this is 8. And so this value is also done. Next, 14 like both tea and coffee. So this entire region is 14. These many people like both tea and coffee. So among these people, 9 are already kept here. Yeah, so this region remaining portion is 14 minus 9, and that is
5.
correct. So this is 5. So we have got all these values. Now, next thing that we have to see is these regions where we have not given any number. Okay. So when it comes to these three regions, 1, 2, and 3, how will we calculate? So they have given T is 30. People who like T is 30. This entire circle is T. So this entire circle are the people who like T. Among them, 9 plus 6 plus 5 are already placed. Yeah. So this is 30 minus of 9 plus 6 plus 5. 6 plus 5 is 11. 11 plus 9 is 20. So this region is 30 minus 20, which is correct. It is 10. Similarly, coffee. So number of people who like coffee are 25. So this entire thing is 25. In that, 9 plus 8 plus 5. These many are already here. So this will be 25 minus of 5 plus 9 plus 8. So what is this answer?
3.
Okay. And yeah, next, what they've given milk is 35. So among this entire 35, 9 plus 6 plus 8 are already here. So how many are remaining? 35 minus of 9 plus 6 plus 8.
12.
Okay, so got all these values.
Yes, ma'am.
Okay. Yeah, so 25 minus 22, that is 3. And yeah, this is 12. Correct. Okay. So were you taking it down or you are done?
I'm done, ma'am.
Okay. Fine. So moving to the first example, what is the total number of students who like neither tea nor coffee nor milk? So we have found out all these values, but they are asking for this value. This is the rest of the values where people who don't like tea, coffee, or milk. So we know the list of number of people who like tea, which is 30. Number of people who like coffee is 25. Number of people who like milk is 35. So yeah, so people who like tea or coffee or milk is this. So what is the value of this?
90.
Correct. Oh no, no, no. Hmm, hold on. Because it should be U minus of people who like tea, coffee, and milk. Who like neither tea nor coffee nor milk. So yeah, mm, tea is supposed to be need. They should not like tea. They should not like coffee. They should not like milk. So T union C union M. Hmm. Ah, one thing which we forgot to take is the intersection. The everywhere intersection was calculated twice, twice, twice. Okay. So, see, if you're taking this 30 and this 25, you're taking this list of people two times. If you have observed my previous session, you will notice 14 plus 9, we have calculated two times. Similarly, 17 plus 9, two times. Similarly, 15 plus 9, two times. That's why we got the value as 90. Okay, so if we had to actually calculate it, then it is 10 plus, all of that. So starting with 9 plus 6 plus 5 plus 8 plus 10 plus 3 plus 12. So now tell me what is the value of this?
54.
54. Let me see. So this much is 20 because 6 plus 5 is 11. 11 plus 9 is 20. So you have 20. Again, 8 plus 2, 8 plus 12 is another 20. So 20 plus 20, 40. 40 plus 10, 50. 50 plus 3 is 53.
Yes, ma'am.
Okay. So they have asked, so among, this 80 students, 53 students like either tea or milk or coffee. So they've asked the remaining students who don't like any of them. So what will you do? You will take U minus 53. So that is 80 minus 53. The answer is
27.
Correct. So the answer here for this question is 27. So clear with this? No doubts?
Yes, ma'am. I'm clear.
Okay. So what does the second example say? The second example given, how many students do not like tea? Okay, if you, yes. So the second example says, how many students do not like tea? So you have the number of students who like tea. Okay. So among these, how many like tea? 9 like tea. Plus here you have 5. Plus here you have 6. Plus 10. So these many students like tea. So this is 20 plus 10, which is
30, ma'am.
correct. So 30 students like tea. So among them, so among this entire class of 80 students, 30 like tea. So how many do not like tea? The question was how many does not like. So how many does not like? 80 minus 30. The answer is
50, ma'am.
correct. So the answer there is 50. So clear with second example as well.
Yes, ma'am.
Right. So yeah, what is the value of t minus c? So t, c, and n. This is your given question. So this is given as 10, this is given as 12, this is given as 3. So you have 5, you have 6, you have 8, and you have 9 here. Okay. So they have asked those who drink only tea but not coffee. So this was tea, this was coffee, and this was milk. So they've asked only those students who like tea but does not like coffee. So is 9 counted? No, because coffee students are also here. Is 5 counted? No, because coffee students are also here. So in that case, so in this case, what will be the answer? Tell me.
16.
Correct. Because very simple, it is 10 plus 6, which is 16. Clear?
Yes, ma'am.
Okay. So the next example, what is the value of C symmetric difference M? So you're given tea, you're given coffee, you're given milk. So this value given is 9, this is 5, this is 6, this is 8. Again, this is 10, 3, and 12. So this is milk, this is coffee. So they've asked all those students who drink coffee but not milk, plus all those students who drink milk but not coffee. So let's do the first part. That is all the students who drink coffee but not milk, who drink C but does not drink milk. So all those students who drink coffee but not milk, 3 is considered yes. And 5 is considered yes. 9 is considered no because 9 is a part of that milk. So 9 will not be considered. 5 is part of the tea, so they will consider it. Again, is 8 considered no because 8 is also part of milk. So this is your first part. This plus, that is C difference M is done. Now M difference C, that is those who drink milk but not coffee. So 12, yes, it is a part of it. Next, 6, yes, it is also a part. 8, no, because it's a part of coffee. 9, no, because it is a part of coffee. So this will be your answer. So tell me what is the answer?
26, ma'am.
Correct. So the answer is 26. Fine. Clear with this sum?
Yes, ma'am.
Okay. So moving on to the last sum for today, and that is, what is the total number of students who like both tea and coffee but not milk? So they want, you have tea, you have coffee. I'm sorry for that. Yeah, you have tea, you have coffee, you have milk. There was a student who like both tea and coffee but not milk. So they have asked you this group. Okay, so we are given that this is 9, this is 5, this is 6, this is 8. We know that this is 10, this is 3, and this is 12. So now quickly add and tell me. We are supposed to add 10, 5, 3. Yes, 10, 5, and 3. How much?
18, ma'am.
Correct. So, yes, who like both tea and coffee but not milk. Mhm. 1 second. So, oh, sorry, they should like both tea and coffee. I made the mistake. Wait. I forgot to take from the question. They have asked both tea and coffee. They should like both tea and coffee, but they should not like milk. So those who like both tea and coffee, these people like tea, but do they like coffee? No, this 10 does not like coffee. Similarly, from this 3, they like coffee, but they don't like milk. Sorry, tea. So that we will not consider. So this is 5 plus 9. This region is the region who like both tea and coffee. The second condition is not milk. So 9 should be removed from that. So what is the
Then
answer?
only 5.
Correct. So the answer is 5 here. Yeah, clear with this question?
Yes, ma'am.
Okay, so do you have any doubts in any of the Venn diagram topics or blood relation topics?
No, ma'am.
Okay.
I'm clear.
All right, because no, we will not be repeating the topics again due to time constraints. So yeah, if you have no doubts, then that's all for today's session. And let's meet in the next session.
Yes, ma'am. Thank you, ma'am.
Yeah, thank you.